Next two sections of Chapter 8, 8.3 and 8.4, deal with scale diagrams, scale factors, and areas of 2D shapes. First, what we need to understand is the definition of scale factor. And a scale factor, represented by symbol K, is a diagram measurement divided by the actual measurement. So we'll begin that with an example now. This is a diagram model, has a scale of 1 to 12. If the head of the dinosaur model is 8 centimeters in length, how long is the head of the real dinosaur? But every time we consider scale factors, or you look at models, whether it be boats, planes, cars, you're never making them to actual size. Sometimes you're making them smaller than what they actually are. So the scale factor is just a way to let you know if the model you're looking at has been enlarged or reduced. So the scale factor here is 1 to 12. Oops. 1 over 12. And what that means in this case is that 1 centimeter on the diagram would represent 12 centimeters of the dinosaur. So it is actually a reduction in size in this case. And so that answers questions A and B. C, will the value of the scale factor result in enlargement or reduction? For there to be a reduction, scale factor would have to be less than 1. So in this case here, scale factor, 1 centimeter on diagram represents 12 centimeters of the actual head. If you divide it by 8, that number would be much smaller than 1. For there to be an enlargement, and you can think of several cases where you want to enlarge a diagram or model. Think of the parts of a cell phone, or electronics, or the inside of a watch. Really small pieces that will be helpful to have a large diagram or model. And in this case, the scale factor will be bigger than 1. And if we went back up here to answer this question, so the diagram or model is represented by the top, bottom is the actual size, and it's asking here how long is the head of the real dinosaur. If our model is 8 centimeters in length, I'll put the model on top. We don't know how long the actual figure would be, so what we have to do here is cross multiply. So 1 times x is x, and 8 times 12 is 96. So on a model, something that you represented by 8 centimeters in length is really 96 centimeters long on the real dinosaur. And the next question now says a circle has been transformed so that its image radius is 14 centimeters. If the scale factor is 0.4, what's the radius of the original circle? So now your scale factor is your model over your original. So in this case, well, we know what the scale factor is, 0.4. The model works out to be 14 centimeters in radius, but we don't know the original, so I'll just call that x. So again, this is a case of cross multiplication. X times 0.4 is 0.4x. 1 times 14 is 14. And to get x, you have to remove 0.4. And your measurement here in this case will be 56 centimeters. That will be the radius of the original circle. So we do get it here. The model worked out to be smaller than the original diagram. We should expect that as a reduction because our scale factor is less than 1.